Okay, today's lesson is over radicals and rationals, and there's a lot to this lesson, so I'm trying to break it up into 3 short videos. So this is part 1 of 3. It's important that you watch them in order. Now, what we did in class for part 1 is we used our calculators to figure out all these perfect squares, cubes, and fourth powers. Now, you don't need to memorize these. They're all available to you in your calculator, but if you get good at recognizing these, they're going to save you a lot of time. Now, if you want to put them in your calculator, you're trying to figure out like 5 to the 4th, you're going to type 5 and then you use this caret key and then the 4th, and then you can get your answer. And so you can do that for any of them. Okay, but here are the numbers. You can fill those in. So what we want to do now is look at these roots. Now last class I mentioned that when you took the square root of 36, positive 6 works and negative 6 works. And when we have problems like these where they want the specified root, we are going to have plus and minus. Now here's the catch though. It's not always going to be plus or minus. Sometimes it's just going to be the positive. Well, how do we know? Well, it depends what the root is. This one is the square root. Square root means 2. Well, 2 is even, and anytime it's even, your answer is going to have a plus or minus. So the square root of 121 is 11. All right, this next one wants the cube root. The cube is talking about the third. 3 is odd. When it's odd, you're just going to have the positive answer. So now you're saying, okay, well, what's the cube root of 512? Well, if I use my chart, 512 is over here on the chart. And I know it's because 8 to the third power is 512. That means the cube root of 512 is 8. So I know my answer is 8. But I only put the positive when it is an odd root. So on number 3, it's the 4th root. 4 is even, so anytime it's even, I'm going to have plus or minus. And the 4th root of 81 is just going to be 3. This one wants the 5th root. 5 is an odd number, so I'm only going to have the positive. But this one isn't on my chart, so I'm going to use my calculator. And to do the 5th root of 82, I'm going to hit, or 32, I'm going to hit my math button. The math is the third one down on the left. I want option 5 where I can adjust the root. So where the root is, I want 5, and then under the radical, I want 32. And when I hit that, I get my answer is 2. So this is 2, and it's only positive because it's an odd root. Here, cube is 3. Cube is 3, so that's odd. So when it's odd, I'm only going to have the positive, the cube root of 729. Well, 729 is right here on my list. The cube root of 729 is 9. Okay, and it's only the positive. This last one, the 4th root of 625, okay, well 4 is even, so I'm going to have a plus or minus. Now it is on my chart, but let's put it in our calculator again to remember how to do that. So I'm going to go to my calculator, I'm going to hit math, I want option 5, and then I'm going to put the 4th root of 625, which gives me 5. All right, now we're going to simplify radicals. So what we did last time, on number 1, this is what we did last time. We're finding the cube root, so we're looking for groups of 3. So I broke that into 5 and 27, and then 3 and 9, and 3 and 3. So I had one group of 3 that went outside, and then I had the 5 that goes inside, and I remembered to put my root on there, the 3. Why is this not erasing? Sorry. Okay, now let's try this one. This one has no number here, so it's a square root. So if I think about this, the square root of 144 is 12, but now I have to deal with the variables. So what I've got here is 6 x's. And because square root is 2, I'm looking for groups of 2. So here's one group of 2, 2 groups of 2, and 3 groups of 2. So there are 3 groups of 2, so I'm going to put x to the third. And I'm going to do the same thing with the y's. Well, how many groups of 2 are in 10? Well, there's 5, so this is y to the 5th, and that's my final answer. Okay, let's try this again on number 3. This time, I'm doing the 4th root. Well, if you check your chart or put it into your calculator, the 4th root of 16 comes out even. The 4th root of 16 is 2. You could make a factor tree, but everything would end up circled. Okay, then for the variables, well, how many groups of 4 are in 8? There are 2 groups of 4 and 8, and there's one group of 4 and 4, so there's just one z. That's your answer. Okay, let's look and see what happens on 48. Now we're doing square root because there's no number, there's invisible 2. So we're going to have to simplify the radical because 48 is not a perfect square. So I'm going to get 2 and 24, 2 and 12, 2 and 6, 2 and 3. Okay, so I have a couple of pairs. So outside I have 2 times 2, which is 4, and then inside I have the 3. Now let's deal with the variables. So with the A's, I have 1, 2, 3, 4, 5 A's. Because it's the square root, I'm looking for groups of 2. So there's 2 groups of 2, but there's this 1 that's left over, so it goes underneath. With the B's, there are 4 B's, and there's 2 groups, but there's none left over, so 2 goes out, but then nothing goes under the radical. Okay, let's try this again for number 3. So 56 is going to give us, now we're finding the cube root here. 56 is 2 and what? 2 and 28? 28 is 2 and 14 and 2 and 7. So I'm looking for a group of 3. So the 2 goes outside, the 7 goes inside, and I remember to put my 3 on the shelf. Now with the B's, there are 8 B's. 1, 2, 3, 4, 5, 6, 7, 8 B's, and I'm looking for groups of 3. So there's 2 groups of 3, and there's 2 that are left over. With the C's, now I'm not going to keep writing out each time. There's 10, and with 10, I'm going to have 3 groups of 3, but only 1 left over, and that will be my answer. Number 6, 486. Well, I got to simplify that. It's not a fourth root. If you put it into your calculator, if you took the fourth root of 486, you get a decimal. So that is an indication you're going to have to simplify the radical. So 486 divided by 2 is 243. Then I can do 3 and 80, whoops, not 88, 81. 9 and 9, and a bunch of 3's. So I'm looking for a group of 4 because it's the fourth root. So the 3 goes outside. I put my 4 on my shelf because it's the fourth root, and inside I have a 2 times 3, which gives me 6. Now I need to deal with my variables. In 12, there are 3 groups of 4, so I have x to the third. In 10, there are 2 groups of 4, but there's 2 that are left over. Okay, this last thing that we are going to do, we are not actually solving anything. I'm not going to simplify. I know for sure a lot of these simplify. I simply want to rewrite them because today everything is going to say write in reduced radical form. We can't leave fractions in the exponents. So how do we do this? Well, this first one, I'm going to make a square root. Okay, this part right here is the base. Whatever the base is, it's going to go under. Whatever number is in the denominator of the fraction, that is the root, and so it's going to be 3. And then whatever is in the numerator, that is going to go up here as my exponent. But when it's just to the first power, I don't need to write this. So this just simplifies as the cube root of x. So likewise, this one, the 8 goes under the radical, and then whatever my denominator is, that is my root, and whatever the numerator is, that's my exponent, but when it's 1, I don't need to write it. Okay, we're going to skip and do 4, and then we're going to come back and do 3. So on 4, the y is going to go underneath, my 5 is going to be in the root, and then my 4 is the exponent. Notice on this one, my base is a variable. And when my base is a variable, this is the best way to write it. But if I look at number 3, my base is a number. And when my base is a number, there's a better way that we can write this that's going to help us later on in one of our following lessons. So I am going to put 112 underneath and then the cube. Now, this would be 112 squared. You can work it out this way. But for our purposes, it's going to be easier to do the computation this way. So when the base is a number, it's going to be easier to write it the way I've started. Okay, let's look at number 5. So 50 is going to go underneath, and 2 is my root, but when the root is 2, I don't write it. and 1 is my exponent, and when the exponent is 1, I don't write it. So anything to the 1/2 power is the square root of the number. Okay, over here, 42 is going to go underneath, 5 is my root, 3 is my exponent, but my base, it's a number, and when the base is the number, it's more helpful for what we're doing later to write it this way. Okay, over here on number 7, okay, z is going to go underneath, 2 is my root, 3 is my exponent. On number 8, 25 goes underneath, 5 is my root, 2 is my exponent. But since this base is a number, it is going to be easier later on if I write it like this. Now, if you calculated both of these things out, you're going to get the exact same answer. Believe it or not, they're actually equivalent. But for our solving purposes, this way is going to be easier when the base is a number, and this way is going to be easier when the base is a variable. Okay, this is part 1. There are 2 more parts.